Hey everyone, we're working with angles today, continuing on with our geometry basics, um, laying the groundwork for everything we're going to need going forward as we move forward in geometry. We start working with triangles and shapes and circles and everything like that. So let's get going. Um, we're going to introduce array. Array is part of a line consisting of one endpoint and then all the other points of that line from one side of the endpoint. So we kind of look at it. There are 2 points. It has 2 points, and we have to name the array in the order of the endpoint and then the other point on the array. So we have a drawing. We have our drawing of our array AB. It can only be called AB. It can't be called BA, because that's not the way the array is going. The array is starting at point A. There are no, in relation to this array of the drawing, there are no points to the left side of A here. It only goes through B and on to infinity that way. So the array has to be named from the endpoint forward. Does that make sense? Okay, opposite rays. This is a little crazier. What they are, they're two collinear rays that share an endpoint. Again, we have a picture for an example. I have my two collinear rays. They start at point A. They extend in opposite directions. So point C, A, and R in this example here are collinear. So ray C, sorry, this should be ray AC, typo. Whoops. So ray AC is an opposite ray to ray AR. They have to start with the first letter of the ray has to be the endpoint, and then it tells you which point it's going through. So point A, ray AC here and ray AR are opposite rays. Sorry about the typo. All right, so for you, I want you to take a few minutes knowing that we have to name rays by the endpoint and then the point they go through. And then line segments can be either order. So your line segment can have line segment FE, and then it could also have line segment EF. It's the same line segment. It has two different names, so remember that. I'm going to take a few minutes to go through and name all the different rays and line segments you see in this picture. There are 12 of them. If you come up with all 12, awesome. If you miss some, that's okay. It happens. But take a few minutes, enter all your answers in Edpuzzle. I'm going to have you kind of write them all out and type them all out in Edpuzzle. You can just type segment, whatever, ray, whatever, rather than trying to get the lines across the top. And then come back and check and see if you got them all right. Okay, so these are all the ones I found. Segment BC, segment CB, segment UC, segment CU, segment UB, segment BU. Then we had ray BC starting at point B going through C, ray CB starting at C coming back through B. I have UC going from U to C. I have CU, which is really CB. It's just a different name for the point. Then we have BU and UB. Does that make sense to everyone? Okay, let's move on because we need to introduce what rays are to talk about angles. An angle is an object formed by two rays that have a common endpoint. And then they also have a vertex, so that's the common endpoint of the two rays that form an angle. We have a picture of our angle in the box there. You can see what they look like. Obviously, I think we know what angles look like as we get talking through them. With angles, there are three ways to name them. We can name them by the letters. So we're going to name our angles by the letters. If you look at the letter in the middle, it's always going to be just named by three letters. The letter in the middle is always the angle at the letter at the vertex. So every angle will have a letter at the vertex. That's the letter we want to put in the middle of our angles as we're talking about them. Does that make sense? Okay. We can also call an angle, we can name an angle by a vertex. If the angle is kind of sitting out by itself, we can call this angle angle X. It works that way. We just name it by the vertex. And then what you're also going to see is by numbers. Usually an angle will have a number inside it. We can call it by angle 3 or angle 4 or angle 5. You'll see as we kind of go through some examples today why we're calling them by numbers rather than letters and vertex. Does that make sense how to name stuff? All right, so let's get moving on again. So here we go. We have the diagram to the right there. I want you to name the vertex of the 4 numbered angles. So look, there are numbers inside. Name the vertex. Then I also want you on the 4, the next thing is find another name for each angle. Take a few minutes, enter your answers in the Edpuzzle again, and then come back and check your work. All right, so here we go, what we should have had. Angle 4 has a vertex at point T. Even though there are a couple of angles there, we're still going to call it point T because that's the vertex of that angle. Angle 1 is clearly W. It's the only angle that's there. Point 2, or angle 2, sorry, that vertex is a point B. And then angle 5, again, is point T. But we can't say, we'd never be able to, in this diagram, call it angle T because there are 3 angles there. We'd have to either name them by the numbers or by the letters, which you should have done on the next example. We have angle 4, we could call UTS or STU. The order of the letters doesn't matter. It's still the same angle. We can name it 2 different ways. Same thing with angle 5. We have WTF and then STW. I think that's angle, that should have been angle 2, I'm sorry there. Don't worry about that one if you got that one wrong. Don't worry about that. What was there, I think, was SPV. So we also would have called that BTF. And then angle 1 there, that should be either TVW or VWT. Does that make sense? Okay. When we talk about angle measures, angles are measured in what they call 1/360th of a circle. So every point of that is a measurement in a degree around the circle. And then the same thing with segments and stuff and other objects. If there's no M or anything, we're talking about the object, we're going to use the congruency statement. So we could have 2 angles are congruent, or when we're talking about the measurement, we're going to put an M in front of the angle. So the measurement of angle A. Then we can say that it's equal. If we're just talking about angles being congruent, we're not really talking about the measurement, even though the measurements are equal. Okay, angle classifications. Some of these you know. Take a minute, try to fill them in, the ones you know. Basically what we call the angles. And then we'll talk about some of the other ones. So can we remember, what do we call angles that are less than 90 degrees? That's an acute angle. I hope we got that one. Those are the ones we know. We basically should know these 3. You've heard them many times over and over. An angle that equals 90 degrees, we obviously know is a right angle. And then angles between 90 and 180 degrees, those are our obtuse angles. What's new, I think, to everybody now are these angles that equal 180. Well, when you think of that, we'll talk about it in a minute. That's really just a straight line. So it's called a straight angle. 180 degrees, it's kind of open up all the way down. Think of it the diameter of a circle. That's a 180 degree angle. So it's a straight line. Angles that are 180 to 360, they actually call those reflex angles. Because later on in geometry, you'll actually start talking, not geometry, and later on in math, you'll actually start talking about them rather than in 180, you'll still talk about them as it's a 120 degree angle because it just flips around all the way. Think of it that way. And then the last one, 360, that's a full, think of a full circle. That's why it's called a full angle. All right, what I want you to do here in this example is on the diagram, find the angle, come up with another name for it, whether it's a letter, a vertex if you can, or different order of letters, and then kind of tell me, is it an acute, a right, an obtuse, a straight, a reflex, or a full angle if you can determine what it is. You should be able to tell all the different ones what they are. So again, take a few minutes. I'm going to have you plug your answers into Edpuzzle again, and then come back and check your work. All right, so this is what you should have found. I tried to list all the names of the possible angles if you had something different. Don't assume you were wrong just because it's not listed there. You probably were right, and I just missed it as I was going through trying to find all the different answers. But MRT is an acute angle because we look and see it's less than 90 degrees. VNQ is obtuse. It is a little bit further back, leaning back kind of than a 90-degree angle. Angle 4, where we see there is PQR or RQP. Again, that's an acute angle. QRS is the line, so it's the points, the 3 points. That is our line. So that's a straight angle. And then angle 1, this small angle up here, again, we definitely see is acute. In that type of diagram, I want you to use it and assume what you see is correct. This is the best way to say it. If we're asking for information based on a diagram, then assume the diagram you see is what you see. So if it looks like an acute angle, it's an acute angle. If it looks like a straight angle, it's obviously a straight angle. If it looks like an obtuse angle, it's an obtuse angle. The only thing you can't ever assume is, even though it looks pretty good, no matter what you're looking at in geometry, you cannot assume that that is a right angle. Right angles will always have this little box in the corner to identify them as right angles. So if you see something that looks like a right angle in a diagram, don't assume that it is, ever. It'll only be a right angle if it has the box in the corner. It's important because a lot of stuff when we kind of talk about geometry is like I always talk about, don't assume the pictures are correct, because there'll be examples where you're going to see a diagram of an angle or something and solve for x and find out that actually what ends up happening the way the diagram's drawn is the smaller angle ends up being bigger once you start solving for variables. It's happened a couple times in stuff that I've worked on, so always be careful when you're looking at that. Again, congruent angles we talked about, they're angles that have the same measurement. When you're looking at diagrams or pictures, they're going to be marked with these little half arcs in the corner of the angle. The number of arcs will tell you what angles, kind of like the tick marks for segments, line segments. If there are 2 angles or 4 angles that are congruent, but they're not all congruent together, 2 are congruent to each other, and the other 2, then you'll have arcs. Like here we have these 4 angles are congruent. If I'm going to talk about F and C being congruent, I'm going to draw in 2 arcs there, so they're congruent to each other. So you got to kind of match up how many arcs are in each angle. Okay, those are all congruent as we do it. Does that make sense? Okay. Here again, we're going to bring in a lot of algebra as we start working through this stuff, because we know all the relationships with our angles. We're going to talk about some more on Monday that'll bring in even more algebra. But a lot of what we're going to do is bring in algebra to the geometry to kind of teach you all the concepts you need to know without having to do all the proofs. So here we're told in our figure, BA and BC are opposite rays. So they're talking about this line, so that tells me right away it's a straight angle. Those are 180-degree angles. Okay? Something you need to remember. They also tell me that angle ray BD, this ray here, bisects EBC. So that angle from E to C here, I'm just going to kind of draw a little loop around it. That angle there is bisected by BD, and if we remember, a segment bisector bisects a segment into 2 equal parts. The same thing with an angle bisector. Angle bisectors create 2 equal angles, so I'm actually going to draw in that these are congruent. So those 2 parts of the angle are congruent, and that's what they're having us find. They tell us that angle EBD measures 4x plus 16, so I'm just going to write that right in here. 4x plus 16. They also tell us that DBC, the other side, equals 6x plus 4. And they want us to find the measurement of angle EBD. So like I said, we know that's a bisector. I know those 2 angles equal each other, so we just set up our equation. 4x plus 16 equals 6x minus 4. Or sorry, plus 4. And now we're just solving for x again, like we have been doing all along. I'll subtract 4x from both sides. That's our first step. So I'm left with 16 on one side equals 2x plus 4. We'll subtract 4 from both sides then. And I end up with 12 equals 2x. We divide by 2 and you find that x equals 6. I need to find out what the measurement of angle EBD is. So I have 4, x is 6 plus 16. That tells me this is 24 plus 16 equals 40 degrees. So that tells me that this angle here is 40 degrees. What I also then know is DBC is 40 degrees because of my angle addition thing. It's two angles, add them together, they equal. So BDC is 40 degrees, but then EBC is going to be 80. It's 40 plus 40. And then as we go on, we'll learn I can do this angle here now from EBA is 100 degrees because the whole thing has to add up to 180. We'll learn that tomorrow. Or Monday. But that's just all the angles, we can add all the angles together. And even though that ABC is still an angle, if we add all 4 of those angles together, they should all equal 180. Make sense? Okay, your turn. Take a few minutes, work through this problem, and answer it in edit puzzle one. At what x equals and what the measurement of angle EBC is. It's a slightly different problem, but you should still be able to figure it out. And then come back and check. Okay, so here we go. The solution to this problem was EBD is 4x minus 8. But then they tell us EBC, so it's the whole angle is 5x plus 20. So again, if I kind of draw an arc here, this is all 5x plus 20. They want us to find the value of x and the value of that big angle, but they haven't given us everything we need, but we can figure it out because I know EBD is the same as DBC. They have to be equal, so it's 2 times this angle is going to equal 5x plus 20. That makes sense. Okay, so now I just distribute 8x minus 16 equals 5x plus 20. Subtract 5x from both sides. We have 3x minus 16 equals 20. We're going to add 16 to both sides now. We end up with 3x equals 36. So x equals 12. So we got half our answer. X equals 12. We plug that back into our whole equation. We end up with 5 times 12 plus 20 is going to equal the measurement of angle EBC. We know that works out to 80. So it's 80 degrees. So angle EBC equaled 80 degrees. Hope everybody got that. If you figured out that it was x equal 28 and got, what's that going to work out to be, like 170? Again, that's okay. I understand how you made that error, 160. I can understand how you did that. You just forgot that these two angles are the same measurement, so I had to multiply it. So this really side is 4x minus 8 as well. All right, moving on. Angle relationships. There's special angle pairs, we call them, that are identified by relationships either to their position relative to each other, or on the next slide we'll find out based on their measurement. So first are adjacent angles. Adjacent angles are angles that have a common vertex and share the same ray for a side. So look back to our example here. If we kind of wanted to draw that out, I have, we can do it this way. These two angles are adjacent angles. We could also kind of have it as this. My angles here are adjacent angles because they share a side. I will highlight the sides that they share so you can see them. They're sharing this side, they're sharing this side. That's what they mean by when they say they share a side. Make sense? Okay. Next one. Linear pairs are adjacent angles that the uncommon sides, so the sides that they don't share, are opposite rays. And what I actually did my first example here, when I drew it, this is a linear pair. The opposite sides are a straight angle, or opposite rays. Opposite rays are always collinear, so they're always going to form a line, so that's how we find the linear pairs. Make sense? Okay. And the last one, the vertical angles are formed by crossing lines that share a vertex and are opposite each other. So if we had two lines that crossed, our vertical angles are the ones that are opposite each other. They all have the same vertex. So each pair of intersecting lines forms two pairs of vertical angles. Makes sense. Does that make sense to everyone? Okay. So here's some more pictures. They're kind of blurry, I apologize. But you can see the adjacent angles. They have the same vertex. They share a common side in the middle. It doesn't matter how big or wide the angle is, they share the side. Again, linear pairs is a special type of adjacent angle. It's formed by a opposite rays and a common side. It is always going to add up to 180 as well. And then the vertical angles are the crossing lines. So we have angle 1 and angle 2 are the vertical angles. Does that make sense to everyone? Okay. The second set, vertical angles are also part of the second set of special angles. These are the ones that are related by their angle measures. Vertical angles are congruent. They have the same measure. The way the angles form, the cross lines form, vertical angles will have the same angle measurement. The second set of angles that are complementary angles. They are angles where the two angles, that when you add up the measurements of their angles, they're going to equal 90 degrees. Those are complementary angles. So you'll think of it, you'll more often than not see them drawn this way. So I know angle 1 here is a complement of angle 2 because 1 plus 2 is 90 because I have a 90 degree angle. Does that make sense? And then we have supplementary angles. There are two angles that when we add up their measures, they equal 180 degrees. Again, this is where we get our linear pair. We have our opposite rays here with our vertex. Here, angle 1 plus angle 2 here is going to equal 180. So when you hear angles of supplementary, always go right to, okay, they added to 180. It'll be parts of words and examples where they kind of have angle 1 and 2 are supplementary. Angle 1 measures 3x plus 5. Angle 2 is 6x minus 13. Find the value of x. And you have to remember that I got to add them up and they equal 180. One last thing we learned, perpendicular lines. In algebra, we learned perpendicular lines are lines that have opposite reciprocal slopes. That is the algebra definition of a perpendicular line. In geometry, we just use the basic one. Two lines that cross to form four 90-degree angles. So it forms two sets, or actually, this is the only example where vertical angles are all congruent. So the two pairs of vertical angles with the cross lines are all congruent. Because when you think of it, if I kind of put an angle 1 and angle 2 here, they're vertical, they're congruent, they're both 90 degrees, but angle 3 and angle 4 are also vertical angles to each other, but they're also 90 degrees, so they all kind of tie together. Does that make sense to everyone? All right, so here we go. The perpendicular lines, they intersect to form right angles. They intersect to form congruent adjacent angles. Again, they share, 1 and 3 share a side, non-common sides. The segments and rays, the perpendicular to lines of other segments and rays, so everything kind of crosses. the right angle kind of thing here, my little box here, that tells me that those line segments are perpendicular because they formed a right angle. They form one right angle, they have to form four right angles. And then the way we always see it in written in words is this way, with that upside down T, that tells you segments are perpendicular as well. All right, so we're looking at this example. If the measurement of angle RTS equals 8x plus 18, they want us to find the value of x so that TR is perpendicular to TS. So we're trying to determine if these are perpendicular lines. I'll kind of do them in red here. They're trying to determine if these are perpendicular to each other. What they really want is just what's the value of x that will make this a right angle. We don't know it's a right angle yet. They want us to make it a right angle, so we need to find the value of x. To do that, I know the angle measurement they tell me is 8x plus 18. For that to be a right angle, that has to equal 90. So now we're just solving for x. Subtract 18 from both sides. We end up with 8x equals 72. So when we divide by 8, we end up x equals 9. So when x equals 9, I know these two line segments or rays are perpendicular. Does that make sense? Does everybody see that? There'll be a lot of work we do of setting angles equal to 90 and 180 degrees to solve for x values. All right, so here's two examples for you to try. The first one is figuring out a value to make them perpendicular. Second one is some things I just want you trying to figure out. Can you assume from the example there what they're asking? Okay, we'll do the second part. Oops, I didn't put the answers in. Sorry about that. All right, so we'll do this one here. So they want to find out and make PTR right angle. I need my pen back. The pen went away. There we go. It's coming back. Sorry about that. So we're trying to make PTR right angle. They tell us that PTQ is 3y minus 10, so I'm going to write it in here. They also tell us QTR is y. So for it to be a right angle, we need to find the value of y to make PTR 90. So that's going to tell me that 3y minus 10 plus y has to equal 90. So 4y plus 10 equals 90. 4y is going to equal 100. So y is going to equal 25. When y is 25, that makes PTR a right angle. All right, so in the diagram, can we assume WZU is a right angle? Yes or no? That would be a yes, because it has the box. It has our little indicator in the corner there that tells us it's the right angle. That's your explanation. Can we decide if YZU and UZV are supplementary? So we're looking for YZU, this angle here, and this angle here. I'm just going to make them look, they're not congruent, they're just, I'm highlighting the angles. Are they supplementary? We're going to say yes here. I'm going to call them supplementary because that definitely is a straight line. So yes here, and that's because they're a linear pair. And the last one is VZU. Let me kind of erase the stuff I have in there. Is VZU adjacent to YZX? So VZU is this angle in yellow. Kind of color it in yellow. And then YZX, I'll color in purple, is this angle. Are they adjacent? And the answer is no, they do not share any sides in common. What they actually are vertical angles. So I hope that makes sense. We're going to build on a lot of this tomorrow. This is just the basics of angle stuff. What we're going to work on Monday is everything we really need to know. So have a good weekend. I will see all of you in class on Monday, and we'll pick it up from there.